Okay, number 17. For a certain rectangular region, the ratio of its length to its width is 35 to 10. Okay, so I've got this rectangular region and its length to its width is, the ratio is 35 to 10. That's not the actual numbers of it, but it could be. But the ratio is 35 to 10. So if the width of the rectangular region increases by 7 units, how must the length change to increase this ratio? There's a couple different ways you can look at it. I'm going to show you the sort of mathematical ways that will work for every single problem. And then we're going to go over here and look at ways you could solve this particular problem just by looking at the answers. I don't want to start with that because there's no guarantee if you get a similar problem on the SAT that they're going to be as nice as they are with the answers here. Because honestly, I think you can get this right without doing any math. But let's show you the math because you need to know the math. All right, so I am just going to use these actual numbers, 10 and 35, for my first go at this, my first method that I'm showing you. Because it works. The ratio is 35 to 10. So it could be actually 35 inches by 10 inches or 35 feet by 10 feet. So the width is increased by 7. Okay, so the width increased by 7. Now I want to keep that same ratio. How much got added to the 35? Okay, so I'm going to set up a ratio. It started, the width was 10 and the length was 35. And then 10 plus 7 on the top, the width went up to 17. And the bottom went up by some unknown amount. And I can solve it just as it is, and I can solve for x. And so I can cross multiply. I can do it like this. 35 times 17, that is 595. And when I'm cross multiplying these, I'm distributing. 10 times 35 is 350, and 10 times x is 10x. So I'm going to subtract 350 from both sides to get rid of it. So I'll only have that 10x over there on the right. And when I do that, I get 245 on the left and 10x on the right. I'm going to divide by 10 on both sides to get rid of that 10 times x. I'm undoing it. And I get that x is equal to 24.5. So that was the increase. It had to increase by 24.5, and that is B. So there's my answer right there. So that's one way you can do it, by using this ratio and using like a real world scenario. Another way that you can look at it, and this may make more sense, the reason I'm showing you multiple ways is I want you to have multiple tools at your disposal and say what makes the most sense and what's the fastest, and that's what you're going to do. Okay, another way you can look at it is just look at the ratio. Okay, so it's 35 to 10, or I would even simplify that just to make it really sort of simple. And I'm going to, not in the strict sort of how we simplify fractions way, but just so it's more of like a quick ratio, like 5 to 1, 6 to 1. If I divide them both by 10, I would get 3.5 to 1. Okay, so this is a ratio of 3.5 to 1. If the width is increased by 7, so that width, the increase. Now I'm just thinking about not the actual full length, but the increase. I'm isolating the increase. So it was increased by 7. How do I get from 1 to 7? I multiply by 7 because we're talking about fractions here. If we're scaling them up, scaling down, we have to be multiplying, not adding. Okay, so then on top, to get the same, like how much was that increase, I have to do the same thing. 3.5 times 7, and that gives me 24.5. Same answer. That's another way to look at it. This way, while it's quicker, sometimes that can be a bit confusing because we're talking about, wait, are you saying that the length increases, that the new length is 24.5, the amount of the increase? Again, we want what makes the most sense to you. What's clearest to you, that's the method you should use. Right, and last but certainly not least, for this particular problem, I don't think you even need to do any math. You can just look at the answers. Okay, and we'll just think this through logically. So there's a ratio, 35 to 10. So we know the length is longer, right? If it's 35 to the length to 10 of the width, we know the length is longer. And with ratios, you know, when things stay proportional, they go up. Like say if this was 2 to 1 and we went up, the bottom went up to 2, we'd multiply by 2. What will we need to do to the top? Multiply by 2. It's that principle. You know, we're changing fractions here. Ratios are fractions. We're changing fractions, we're multiplying. We're never adding to keep those fractions the same. They have to be multiplying to keep the fraction the same. And that's what they're saying. We have to maintain the ratio. We have to keep that fraction the same. Okay, well, the bottom goes up by 7. The width increases, goes up by 7. So is the top going to increase or decrease? Well, to keep the same proportion, it's going to do the same, right? If this one goes up, that one also has to go up. The bottom one goes down, the other also goes down to keep that same proportion. So already the two that say decrease are out. I've already eliminated halfway. And then if you have that knowledge that ratios are like fractions, and when we're increasing fractions, we're scaling up, we're always multiplying, never adding. This one says increase by 7 units. That's adding, because this one added 7 units, and it's saying, oh, to keep it the same, you have to add 7 on the top. No, it's a proportion. So if it increased by 7, you have to figure out how much it was multiplied by and then multiply the top by the same thing. So even without doing the math and without figuring that out precisely that it is 24.5, just the fact that our only options are 7 and 24.5, if you have that knowledge of how ratios work, you'd know it would have to be more than 7. It's going to be B. That's sort of like the logic way of doing it. So there's 3 different methods for you. I always say learn as many things, as many ways to do a problem as you can, because you don't know what kind of problem you're going to get on the final test. But hopefully I didn't cause too much confusion by giving you the multiple ways to solve that. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.